Okay. I'm going to need to erase the board so we have room, but most of you know we have quiz tonight around 8 o'clock on chapter 4. I moved the chapter 4 homework back till tomorrow evening at midnight. I think it was for tonight at midnight. I go, well, that's stupid. I just moved it to tomorrow night, midnight. So if you need to put a few more finishing touches on your chapter 4 homework, you have until tomorrow night at midnight to finish that one off. Okay. Like I said, it was supposed to be tonight. I'm going, why? So, all right. So, real quick, we have A, B, C. Pick two equations, eliminate a variable. It looks to me immediately like if I pick B and C, Y is instantly eliminated, and I don't have to do anything to it. Okay, so I'll pick B and C. See, B is negative 8x minus y plus z equals negative 5. C was 2x plus y plus 2z equals 5. Add these together, I get negative 6x, the y's drop out, plus 3z equals 0. And we label that as equation D. Now we go back to the original equations, back at the A, B, and C. Okay, we have to use the unused equation of the originals. That means we have to use A, and we have to get rid of the Y. Because D has no Y's in it, we got rid of the Y's. So we've got to repeat the process, get rid of the Y's, but we have to use A somehow. Well, it seems to me that if I take A and 2 times C, I'll get a positive 2y here to cancel out my negative 2y here. And so I've satisfied the conditions. So I'm going to take A and 2 times C. So A is going to be 4x minus 2y minus 3z equals 5. 2 times C is going to be 4x plus 2y plus 4z equals 10. Okay, add these together, I get my new equation E, which is 8x. My y's dropped out, yay, plus z equals 15. Now, there's several questions last night. What if I didn't, you, speaking for you, what if you didn't eliminate y? What if you decided to eliminate x or eliminate z? No problem. Our steps will be different, but as long as your work is organized, okay, and you don't make an arithmetic mistake, we'll all get the same answer. It's okay. But I tried to guide us so we all kind of did the same thing. So, any questions to this point? Any questions about my equation D or my equation E and where they came from? All right, I don't hear anything. So now I'm supposed to take D and E and somehow eliminate a variable. Okay. In my opinion, and this is strictly me, I would do -3 times equation E. -3 times E, because that'll give me a -3z here, and that'll cancel out with my +3z here. Is that okay with everybody? That's what I would see, but there's all kinds of options here. All kinds. My way is not the only way. Is that okay with everybody or not?
Yeah, let's do your way.
Okay. All right. This is being taped, so you can come back and look at it. Not taped. That's old. God, that's 1970s and 80s. This is being recorded. Okay. All right. So we take D, and I'm going to leave it alone as negative 6x plus 3z equals 0. And I'm going to go for 3 times e. 3e. That would give me 24x. 3 times 8 is 24, plus 3z, 24x, dummy. 24x plus 3z equals 45. I think that's right.
You wanted to do a negative and not a
Negative 24, right?
You're right. You're right. Negative 3. Thank you. Because I wanted to make that z cancel with that z. So negative. So that should be okay. Let's try this again. Okay. So if I did by negative 3, I screwed up already. That's negative 24x minus 3z equals negative 45. Is that better?
Got it. Yes.
Okay. Okay. So add these, my z's dump. Yay. So I get negative 30x equals negative 45. Okay, we're not in the glare yet. Good. Okay, divide both sides by negative 30. I get x is negative 45 over negative 30. Use your calculator to reduce that. Okay. By the way, it reduces by 15s, or you could reduce it by 5s and then later reduce it by 3s. But this becomes 3 over 2 or 1.5. I don't care what you call it. But use your calculator. 45 divided by 30 is 1.5, 1.5, 3 over 2. All of those are the same. Okay. But don't panic. Okay. I know some of you are going, oh, I got fractions and I got to plug them in. It's not going to be that bad. Truly, it's not. Okay. So are we okay with x being 3 over 2? That is right. That agrees with my notes, by the way. I did this afternoon. All right. So now what do I do? How do I get my other variables? What do I have to do?
Plug it into D or E.
Good. Plug it into D or E. Okay. I think I'm going to plug it into E only because I don't like the negative there. And that's just me. You know, it's irrational. Shouldn't matter, but I'm going to. So I'm going to plug it into E right here, and we're going to get 8 times 3 over 2 plus z equals 15. Okay, again, use your calculator. 8 times 3 is 24, divided by 2 is 12. Or some of you know how to cross cancel. Cool, I don't care. 12 plus z equals 15. Take 12 away, so I get z is 3. Okay. Now, take x and z and plug it into either A or B or C. Take the one that looks easier. C? C looks easier to me, and I don't know why again.
There's no
Okay.
negatives in that one.
Probably. I mean, again, that's less likely chance of mistake. So I'm going to go with C. So I'm going to take equation C, and I'm going to get 2 times 3 halves, 2 times x, plus y, which I don't know, plus 2 times z. Z was 3 equals 5. Okay, again, use your calculator, but this will turn out to be 3. Cross cancel, whatever. 3 plus y plus 6 equals 5. Y plus 9 equals 5. 3 plus 6 is 9. Take away 9. Y is -4. Express your answer as a ordered triple, 3 halves. The parentheses are required, 3 halves, comma -4, comma 3. Remember, your ordered triple goes X, Y, Z. Even though you maybe found them, calculated them in a different order, when you express your answer, you express it in the order of X, Y, Z. So that would be your answer right there. So I got the feeling that last night we had a breakthrough. People were getting better and better. How about tonight? You feeling more comfortable even?
Yes.
Okay. What about everybody else who's not talking?
Yes.
Okay. I
I
mean,
missed
because
up a little bit, but I figured it out.
Okay. Yeah, because I had some of you guys thinking, okay, well, I'm going to be working at Burger King the rest of my life. I'm not going to STEM. I'm doing all these things. You were all panicking. What I'm hoping is that you're beginning to get more comfortable as we work through this. And there will probably be on the chapter 5 quiz one of these, and there will be one of these on the exam number 1. There will be a 3x3 on the exam number 1 for you to solve, showing your steps. Okay, I want to move on. Okay, no questions? No one's going to scream at me?
We'll still get partial credit on the exam if because like I have this problem where I'm messing up like on stupid arithmetic early on, and then I'm getting the wrong answer at the end. And
Yeah.
so will we still get partial credit?
Yes, you will.
Okay.
Yes, you will. One of my speeches, and I'm not sure if I gave it at the beginning of the class at the semester, is in my class, it's entirely possible for you to miss every single problem on a quiz or a test and still pass the class, because I try where I can to give partial credit. Okay. A lot will depend upon where you made your mistake and how bad it was. If it was just a silly arithmetic mistake and you continued working with it and your work was accurate with that mistake, then I won't penalize you a lot. You won't get 100%. You might not even get a B, but you will get a passing grade on it. Okay, I try to get partial credit, but here's the catch for everybody. The reason I have these ABCs, the reason I have you labeling, is so I can follow your work. If you just put crap up there and say, okay, here's my work and I made a mistake somewhere and I can't figure it out either. So will you get partial credit? Yes, if I can follow your work. So work real hard on keeping it organized.
Okay, thank you.
Okay, yeah, but my speech wasn't just at you. I hope you understand that. My speech is for everybody. Okay.
Right.
Okay. I mean, I don't want to sound like a parent lecturing. I don't like who you're hanging out with. They're a bad element. Blah, blah, blah. Okay. All right, erase.
Yeah, I think I just have a little bit of dyslexia. So like I'll just randomly throw a negative sign in where it doesn't belong. And then it just messes things up so bad.
Welcome to my life. Or I'll have 3x minus 4 equals 7, or 4x, 4y, let's do it this way. And my very next line, I'll just change the minus to a plus. Why?
Right.
Who knows? And it totally screws up everything I do. I don't know. I keep asking my mom, did you ever drop me on my head when I was a little kid?
I, for some reason, keep on mixing up Z for 2 in my handwriting. So
That's why after years, I got to cross my Z's.
I had to start doing that.
Yeah, that's why I cross my Z's, because my Z's and my twos, without that little cross in there, look a whole lot the same.
Yeah,
So
like the same.
try adopting that. You know, for years I didn't do that, and all of a sudden I'm going, I'm screwing myself up. I'm screwing my students up. I started retraining myself that way. Okay, here we go. Another problem. Okay, this is from last night. We have 5x to the 4th, y to the 7 quantity cubed times -3 x y to the 5th quantity squared times 2x y to the 3rd z to the 15th quantity to the 0 power. Okay, take 2 minutes. I'll pause the video or the recording, take 2 minutes and give that a try. Okay, so here we go. Distribute. So we're gonna get 5 to the 3rd times x to the 4 to the 3rd times y to the 7 to the 3rd times, be careful, this is -3 to the 2nd power. It's all of that number, all of -3. So quantity -3 to the 2nd power times x to the 2nd times y to the 5th to the 2nd. Okay, times what's any quantity, no matter how ugly or important it looks, to the 0 power?
1.
1. So this is a big fat 1, and in effect, it doesn't affect the problem. It just goes away. We don't need it anymore, because we know that anything times 1 is itself. Okay, so now we got into a little bit of trouble last night. Whenever you can do just plain old arithmetic, you do it. So 5 to the 3rd power is 125. But then when you do a power to a power, you multiply. So this is x to the 12. This is y to the 21, power to a power. Times, okay, -3 squared. This is +9. Okay, if you don't like it, now, okay, I'm not going to go into that. This is x squared, nothing fancy. This is y to the 10, and the 1 is silly. Okay. Mentally, this is what you do. You group 125 times 9, number times number. You group x to the 12 times x to the 2nd. You put your x's together. And you group y to the 21 and y to the 10. So this is a mental step. You see, oh, number times number, x times x, y times y. Okay. So I don't know what's 125 times 9. 1125.
Yes.
Yep.
Did I get it right?
Yeah.
God, okay. Oh, I'm good. Okay, 1125. Technically, how do we put these two x's? If I have x to the 12 times x to the 2, what do I have? X to the
14.
14.
14. 12 plus 2, which is 14. This is y to the 21 plus 10. So final answer, 1125, x to the 14, y to the 31. Okay, and yeah, there's a lot of room for you to skip steps. But as the teacher, okay, showing you these are what you have to be thinking, whether you skip them or not on your paper, I don't know. I don't care.
So is
But
there
you have
something that you want to see when we're writing this for the exam? Because you're saying we don't have to show all of it. So what would you like us to show?
Well, I think you can go from this step to this step in your head. So it kind of depends on your level of sophistication. But I think from the original problem, okay, you could jump from here to here to here. So you'd have what, 2 steps? But there's a lot of thinking that goes on behind those 2 steps. So I think with that and then jumping to that, that's fine for me. I understand that. Okay, does that clarify it?
Yep.
Okay, again though, please, guys, everybody, if you need more steps, take them. Okay, don't get all fancy and go, oh, I can do all this in my head. No, you can't. Okay. All right. I'm done with that problem. Go on to a new problem. Are we okay? That was the base. That basically covers almost everything we talked about last night with exponents. We got power raised to a power. We got distributive. We got the 0 power in there. We got all kinds of stuff. Okay.
Hi,
So-
Professor. This is Sandra.
Oh, you're in? Okay.
Yeah, sorry. I had Windows updates and it just, yeah.
I'm surprised you're here. Windows updates just
I know those are a pain.
go forever.
Yeah.
I always make it do it in the middle of the night.
Yeah.
Okay,
Okay,
you
thank
should
you.
be on. Are you on? Yes.
Yes.
Okay.
Okay.
All right. Next problem. -18 x to the 5th, y to the 7th, z to the 3rd over 24 x to the 9, y to the 5, z to the 3rd. Take a minute. Again, each one of you comes to this class with different backgrounds, different levels of sophistication. You don't have to show me all these steps, but you sure as heck need to be thinking these steps. So mentally, you should be dividing this problem up in mentally with number, x's with x's, y's with y's, z's with z's, and deal with each one of those as separate little baby problem. Well, 18 over 24 eventually reduces to -3 over 4. Divides by 6. 6 goes into 18, 6 goes into 24. But we learned last night that there was a trick for dividing with exponents. And mentally, what we said is you see 5 x's on top, 9 x's on bottom. Okay, so they're going to cancel out, but that should leave 4 x's on bottom. And it always leaves an invisible 1 behind as sort of a placeholder. So that's what happened with the x's. The 5 x's on top canceled with 5 of the ones on bottom, but left 4 more on the bottom, which is what I wrote. Same thing happened with my y's. Okay, whoops. So I should have y to the 2nd on top. Again, the invisible 1 there as a placeholder in the denominator. You don't have to do that. I'm just being proper and nitpicky. But what about here? What about my z's? Okay.
Cancel them out.
Completely. Or think about this. Way back in grade school, what was 5 divided by 5? 1.
1.
Yeah. And 17 divided by 17 is 1. So we learned that any number a divided by itself was always 1. So this would just become a big fat 1. Or you can just say it cancels out, whichever you prefer. It doesn't matter to me. All right, shove all this together. Final answer, -3y squared, because you're multiplying -3 times 1 times y squared over 4x to the 4th. And that would be my answer. Is that okay with everybody or not? Any questions or clarifications you need on it? Okay. Last problem that I want to do before we get to something new tonight, okay, is this one. -12x to the -5, sorry, x to the -5, y to the -2 over 30 x to the -9, y to the 5. So I'll get out of the way and repeat it just so you can see it. The numerator was -12 x to the 5th, y to the -2. The denominator was 30 x to the -9, y to the 5. I'll pause it, give you a couple minutes to work on that.
I can ask you a quick question.
So once again, we split the problem up, -12 over 30, x to the -5, x to the -9, y to the -2, y to the 5. Again, I say you don't have to do this, but you do have to think this step. Okay.
This helps me a lot.
Okay, well, that's cool. That's why I'm showing you this. If this works, take it and use it. Okay. So now we reduce each one. Question, and this is back to Mitch's question. Does this -12 flip?
No,
Why not?
because it's not a variable.
Not a power.
Not
It's
a
not an
power,
exponent.
not an exponent or not a power, right? It's just a plain old number. Only exponents flip. Okay, only negative exponents flip. So this just reduces, okay, 6 goes into that, 2, 5. It reduces eventually, again, use your calculator if you need to, but it'll reduce down to -2 over 5. Now, in this problem, it would become x to the 9 on top, x to the 5 on bottom. They're both negative powers or negative exponents, so they both flip. And the only where the -5 can flip is down, and the only place the -9 can flip is up. And this caused some headaches last night. The act of flipping uses up the negative. So when you flip the -5 down, it becomes a +5 when it flips. When you flip the -9 up, it becomes a +9. So the act of flipping uses up the negative part of the exponent. Okay, coming over here to this one. Okay, the -2 flips down. So it's y to the +2. What about y to the 5?
That stays.
That
Stays at
stays.
the bottom.
Yeah, it stays in the bottom. It does not flip. See, what I see students doing all the time is they're going, oh yeah, man, everybody and their mother just flips, flips, flips. No, only if they have negative powers do they flip. Okay, so you got to be a little bit discriminating on what you're seeing here. All right, so we still have -2 over 5. Now, here, these cancel out, so we will end up with x to the 4 on top. Okay, here, these don't cancel, they just get bigger. We get y to the 7 on bottom. And again, if you want to put the placeholder 1s up there, you can, you're fine. Shove everybody together, final answer, -2 x to the 4th over 5 y to the 7. And that's your answer. Okay. That okay with everybody? Because that's pretty much a review of everything we did last night.
Would a regular number with a negative exponent be flipped as well?
Yes, it would.
Okay.
Okay, because it's the negative exponent that causes something to flip. So what he's suggesting is, what if you had 3 to the negative 2 power? Okay, then that flips. Okay, well, okay, first off, there's an invisible 1 there. So it flips and becomes 3 to the positive 2 power. Okay, but it's because of the negative power, okay, that it flips, not anything else.
Does it matter that where the negative is on the answer? Or like, is it if it's before the numerator or
No,
the
doesn't matter.
line? Oh,
Doesn't matter. All right. Now I have about 45 minutes. Yay! To get into some new material before we start the quiz. So I want to get into chapter 6.3. So draw a line in your notes or whatever. We're going to start chapter 6.3. And this is polynomial multiplication. Okay, polynomial. It's like a parrot on a diet. Think about that. Polynomial. Okay. Thank you for the pity laugh. I appreciate it.
It took a second.
And there's other people out there going, huh? And then you guys, every once in a while, I'll drop something really, really inappropriate, and you guys will be going, wait, did he say that really? Gotta listen to me, guys. Okay, first off, you need to be, this is really super important. If you had if you had 3x squared times 5x to the 4th, okay, this is exponents. This is pure exponents because it's all multiplication. Very important, because it's all multiplication, then all of those rules that we just reviewed all are valid and good. And so a final answer to this would be 15x to the 6. Multiply the numbers, and then same base, add the exponents. 2 plus 4 was 6. Because this is all multiplication. Same thing here. Suppose I had 2x squared quantity cubed. 2x squared quantity cubed. Again, it's all multiplication. So the rules that we have, 2 to the 3rd power, where we say distribute this times x to the 2nd to the 3rd power, all of those rules we did, 8x to the 6th, all hold. But what happens if we have something like 2x cubed times 3x squared plus 4x? What happens if there's a plus or a minus sign in your polynomial? That was one of the things we talked about a little bit last night. I kind of threw you the term polynomial. It just means a whole bunch of stuff separated by pluses and minuses. Okay, so the outside number was called a monomial, mono meaning 1. This inside is a binomial, bi meaning 2. Okay, but the key thing that I want you to focus on is not the vocabulary, but the fact that this is a plus sign, and that means all of the things that we learned last night are useless. It doesn't apply to this problem yet. However, we kind of know how to do this. We kind of know, we've seen in previous chapters, that we can distribute. So when there's pluses and minuses, we can distribute. So we end up with 2x cubed times 3x squared plus 2x cubed times 4x. So when there was a plus or a minus here, we said we could distribute the 2x squared to everybody, or x cubed. Now, okay, change the focus of your work. Just look at that part of the problem that I've underlined in green. That is all multiplication. So now, because it's all multiplication, I can use my rules of exponents on that part of the problem. And that part will become 6x to the 5. Remember, keep the base, add the powers. 3 plus 2 was 5. Plus, okay, look at this part of the problem. Again, focus in on just that part that I've underlined or bracketed in red. Okay, that's all multiplication. And so for that part of the problem, I can use my rules of exponents. Okay, so if I do, that gives me 8x to the 4. A lot of people go, okay, wait, time out. Where'd you get the 4 power? Well, remember, there's an invisible 1 on that x. So when you're adding the powers, you say 3 and the invisible 1 made 4 x's, x to the 4th. So the moral of the story is, if there's a plus or a minus in your problem, then you can't use the rules of exponents right away. You have to first distribute and then use your exponent rules on that part of the problem, and then use your exponent rules on that part of the problem. Okay, and essentially, that's all that's going to happen in section 6.3. All I'm going to do is start giving you uglier and uglier and uglier problems. But that's basically what we're going to do. We're going to distribute, and then each piece we're going to try and clean up with our rules of exponents. Distribute, rules of exponents. And here's the kicker. Again, depending on your comfort level or your level of sophistication, I believe that many of you, especially by the time you've done some homework, can do this entire problem in your head. You don't need, you need to think about the distributive, but you don't need to show me the distributive unless it helps you personally. So let's try another problem and see how we can screw things up.
Professor, do we still add the 6 and the 8? Or the 6?
Good question. Thank you very much. No, you can't, because remember, these are like, the only thing you can actually add is like terms. So if this, for example, had been 6x to the 5th and 8x to the 5th, then we could have added these and gotten 14x to the 5th. But because this is a 5th power and this is a 4th power, they're totally unlike, so you can't go any further than that.
Thank you.
Is that okay?
Thanks. Yes.
Right. That, again, Richard, right? That was you. I think I was recognizing your voice.
Yes.
Okay. That is a real common problem for students. They get all wrapped up in the little details, and they get down to here and they go one extra step that they can't take. They forget that the only thing you can add or subtract is like terms. Add or subtract like terms. So there's a good clarifying question. Keep asking those guys over and over till we get it into everybody's head.
Wait, answer is 6x5 plus 8x4?
That's it.
Oh, okay.
You're done. I'm sorry. He asked another question, but the answer is 6x to the 5 plus 8x to the 4. And you stop. Because these are not like terms. Because they don't have the same exact variable. Okay, so you just go, I'm done. That's it. I quit. For some reason, Mom makes a big deal. 2a cubed b squared times 6a cubed b minus 3a to the 4th b to the 7 plus 2ab. Okay, for some reason, all textbooks, and Mom is essentially a textbook, like to come up with these really crazy convoluted problems. And the truth is most of the time, your work won't be as ugly as this. But let's take a second and make sure you can do this, because there are a few problems in the Mom homework for chapter 6.3 that are kind of like this. So take a second. Okay, I'll pause the recording. Okay. Here we go. We're going to distribute 2a to the 3rd b to the 2nd to each term in the polynomial. So we're going to set up a series of baby problems. 2a to the 3rd b to the 2nd times 6a to the 3rd b minus, okay, 2a to the 3rd b to the 2nd times 3a to the 4th b to the 7th plus, okay, 2a to the 3rd b to the 2nd times 2ab. Okay, so notice the minuses and the pluses from the original problem just come down. And I distributed the 2a to the 3rd b to the 2nd to each piece of the problem. Now, if you just look at this part of the problem only, where my hand is, only this part, because it's all multiplication, I can use those rules of exponents to just this part. So this becomes 12, a to the 6, b to the 3. And I skipped some steps there. I'm using the add the power stuff. Is everybody okay with where b to the 3 came from?
Yeah.
Did everybody get the invisible 1 power on the b out here? Okay. Then we move to the next one. There's a big fat minus in the middle. Again, when we look at this, only this part of the problem, only this chunk of the problem, it's all multiplication. So now, because it's all multiplication, we can use our rules of exponents. This is 6, a to the 7, b to the 9. Okay, moving on. Plus, same argument, it's all multiplication. So this is 4, a to the 4, b to the 3. Okay. Can I add any of these together? Or subtract any of them together? Can I jam them together in any way.
Can you add the b cubed?
To whom? No, this is all one, this is one term. So this animal is a6b cubed. If you're going to add it, it has to be to an a6b cubed. What I hear you trying to say is you want to add this and this because they both have b cubes. Is that what I hear you saying or not?
Kind of. Now I'm kind of just confusing myself at this point. I thought
Okay.
I saw something.
They have to have all the variables the same. So even though they both have a b to the third power, those a's are different, so they're all different. They would have to be exactly the same variables everywhere for you to be able to add.
Okay, that makes
You
sense.
can't even do the beginning numbers like 12, 6, and 4. Could you
Nope.
work those?
Can't do those. Because think of these as animals. I have 12 African bananas. I don't know what those are. I have 6 American baboons. Okay. And even though they have all A's and B's, they're all different. The 12 is associated with these. So if you're going to add it, you got to add it with something else that's exactly got an A to the 6, B to the 3rd. Exactly. So if you wanted to add that, let me give you an example. So you had 12, A to the 6, B to the 3rd. If you wanted to add that with something, it would have to be an A to the 6, B to the 3rd. It would have to be the same variables. And then you get 17, A to the 6, B to the 3rd. Okay, so the only thing this adds with is another exact same variable.
So that 3-part expression is the entire answer.
Yep.
Okay.
Yep. Yeah, because none of these were like terms, so I quit. Okay, now let's see, how can I put this gently? This is boring. We want to come up with something much more exciting. Okay, you guys are going,
What?
yeah, right. Yeah.
No, it's fun.
Okay. Now, watch this. What if we had, I'll start easy, 2x plus 3 times 5x squared plus 7x minus 2. What if I had a binomial times a trinomial? Okay. Now, I'm going to show you the traditional way this is taught. And then I'm going to come and show you a slightly different way. And then I'm going to say, I don't care which way you do it. Okay. The traditional way that this is taught, okay, is you distribute the 2 to everybody here. So let's do that very slowly. 2x times 10x, 2x times 5x squared is 10x to the 3rd. 2x times 7x is 14x to the 2nd. 2x times minus 2 is minus 4x. Then we say, oh, I've distributed the 2x to everybody. So now you're going to distribute the 3 to everybody. So, okay, let me underline this. This underlined in green is when I distributed the 2x to everybody. Now I'm going to distribute the 3 to everybody. So 3 times 5x squared is plus 15x squared. 3 times 7x is plus 21x. and 3 times -2 is -6. So the part, when I distributed the 2, I used green ink, and this is the result of multiplying everybody by 2x. Then I multiplied everybody by a 3. Okay, 3 times everybody, and this is that result. Now, are there any like terms? Be careful, there are.
Yes.
Okay. Are there any x cubes anywhere?
No.
No. So I just bring down the 10x cubed. Are there any x squareds anywhere? Yeah,
Yep.
there's 14 of them here and 15 of them here. So there's 29 of the x squares. Okay. Are there any x's? Yeah. -4 here, plus 21 here, plus 17 x's. And the -6 just comes down because there's no more numbers. So that's my final answer.
Excuse me.
Okay.
You will combine 14 and 15, but
Yes.
what happened about x?
The
X-
the x here.
No, for 14x2.
Yeah.
Yeah, wouldn't it be 29x to the fourth power?
Okay. Hang on. Wait a minute. Let's back up. Suppose you had x to the third plus, suppose you had 3x to the third plus 5x to the third. The rule for like terms is we add 3 plus 5 and keep the x to the third. So we get 8x to the third. Okay. But if you had 3x to the third times 5x to the third, then we get 15, 3 times 5, x to the 6. So to answer your question, when you're adding or subtracting like terms, the variable does not change. When you're adding like terms, okay, it stayed x cubed. When you're multiplying, the power changes. Okay, adding or subtracting, power doesn't change. Multiply, divide, power changes. So I know you're not the only one, and this is, again, you guys keep asking me these really good questions that all students stumble on. So when you're doing this and this, you're adding, so the power won't change. The 14 and the 15 make 29. The power doesn't change because you're adding. Okay. It's a confusing concept. Just keep working, keep asking. Okay. Now I want to erase this problem and show you an alternate way of doing the same problem. And then you get to pick whichever way you want to do it.
Is it easy?
I don't care. Okay. So are you guys kind of okay with this method? This is the way that almost everybody teaches multiplying polynomials together like this. They talk about double distribute. Distribute the 2x to everybody, distribute the 3 to everybody, and then combine like terms somehow. Okay, I would say 98% of the world does this problem exactly the way I've shown you. So, how about another way? A slightly different way of teaching this exact same problem is to build a matrix here, where you put your 2x and your 3 here, and then you put your 5x squared, 7x minus 2 across the top. And then you do individual multiplication. For example, 2x times 5x squared is 10x to the third. Okay, 2x times 7x is 14x. 2x times 2 is negative 4x. Okay, the advantage of this is that it organizes your work for you. 3 times 5x squared, okay, is 15x squared. 3 times 7x is 21x. Oh, this
14x should be squared, right?
x squared, right? Okay, and 3 times 7 is 21, and 3 times 2 is negative 6. So the matrix keeps things organized. You still have to go through and combine like terms. You still have to do this, but the matrix here kind of keeps it nice, neat, tight, and organized. So you go, okay, how many x cubes do I have? 10x cubes, 10x to the third. My x squareds are right there, so I have 29x squared. My x's are right here. 21 take away 4 is 7, positive 17x, and then the minus 6. So again, a lot of students like this method, because it keeps your work organized and it keeps it nice and neat and tight, and people just like it. Okay. Again, I showed you the traditional way where you just write everything across the board and then combine like terms. I've showed you this matrix, or sometimes just the box method. Okay, doesn't matter to me which way you use. What matters is you get this answer. That's all I care about, that you got this answer. All right,
Do
you
you
want to
have-
try? Go ahead, I'm sorry.
Do you have to write it in order? Like I've
Yes.
noticed that it's always been like cubed, squared, so on and so forth.
All right, really, really good question. If you have a bunch of different variables, then I don't care who the instructor is. It doesn't matter what the order is. It doesn't matter, did you put your X's first? Did you put your Y's first? Did you put your Z's first? So if they're all different variables, then you can throw the answer up in any order you want. If you want to say 3z squared plus 7x to the third plus 5y to the 9, that's cool. You can do that. You get 100% credit. Okay, but if they're all x's but different powers, really important, they're all x's but they're different powers, we always put them in what's called descending order of power. Highest power first, next highest power, next highest, and so on. So let me go back. If they're all different variables, x's, y's, and z's, then nobody cares what order you put them in. You can scramble them up any way you want. But when they're all the same variable, just different powers on the variable, then we always put them in highest power first, next highest, and so on, till the last number is the lowest power or no power. So Carmen, did that answer your question?
Yes, it does.
Okay. It again, it's one of those things where there's no clean answer. All right, let's try any way you want to do this problem. Okay, you try this problem. 3x minus 5 times 6x squared minus 7x plus 2. I don't care which method you use, work that problem out. Simplify it. Okay, so I set it up as a matrix problem. Okay, so we're just going to start multiplying. By the way, the cool thing about the matrix is you can get really bizarre. For example, you can say -5 times -7x is 35x. You can do it in a totally random order, but the matrix, the box, will organize it for you. So you can just start multiplying these any old dang way you want. -5 times 2 is -10. Okay, any way you want. Notice something, somebody asked and it didn't get in the recording. You have to treat that as a -5 when you put it in out here as the matrix. But let's fill this in. 3 times 6 is 18x to the third. 3 times 2 is 6x. -5 times that is -30.
I think you have that 35x in the wrong square, right?
Oh, you're right. Down here. Better? Thank you.
Yes.
So maybe we shouldn't do it in random order. And what would this be? -21x? Is that right? X squared? Okay, wait, I'm busy talking. Talking and writing is not a good thing. 3 times 6 is 18x cubed. 3 times 7 is -21x squared. 3 times 2 is 6x. Yeah. 5 times 6 is 30. 5 times 7 positive 35x. Yeah, okay. So notice something. If you did it the other way, if you distributed the 3x to everybody here, this is the row that you should have gotten when you distributed the 3x to everybody. Okay, if you did it the traditional way. And then if you distributed the -5 to everybody, this is the row you should have gotten when you distributed the -5. So the work is all here, it's just in a little bit different order. So let's do it. I have x cubes, 18x to the third. X squareds, I have that, so I have -51. 30 and 21 make -51 x to the second. Remember, when you're adding or subtracting, you don't change the power. 6 and 35 is 41 of the x's, and the -10 just goes along for the ride. So that would be my final answer. And again, I don't care the method you use as long as you got there. Okay, is that all right with everybody?
That's 41 X's, right?
No, I got that wrong.
Oh, crap. Yes, thank you. Sorry, I'm sorry, somebody said no.
Never mind, never mind.
Okay,
I will say I like that method.
okay. In the end, again, I don't use it. I use it when the problems get more ugly. I use the traditional method when it's a binomial times a trinomial. But if some bozo gave me a trinomial times a trinomial, okay, then I go to this method because it really helps organize things. So I just kind of bounce in between. And you can do whatever you want. All right. I want to leave you with one thing. I have 6 minutes before 8 o'clock. I said I'd quit around 8. Okay, so we can take the quiz. I want to leave you with one more thing. Okay, and it's still all related to this multiplying stuff. So can I erase this problem and its matrix and its answer? Okay, here we go. Then this is a trick question. suppose I had 2x minus 7 quantity squared. Okay. Because of the minus, you can't use the exponent rules. Remember, the exponent rules only are good if everybody is multiplying inside there. They're not. That's a 2x minus 7. Okay, so you can't use the exponent rules. Okay, and I don't care what you say, this is not 4x squared plus 49. You can't say this is 2x squared plus 7 squared. You can't distribute the 2 to these things. That's what I'm getting at. That's an exponent rule, okay, applied to the wrong situation. So you can't do this. These are all wrong answers. So what do? Well, you go back to fundamentals. What does the power of 2 actually mean? Well, it means somebody times itself. And now it becomes exactly what we were talking about. You put a 2x and a minus 7 here, and a 2x and a minus 7 here, and you fill out your matrix. So what I'm trying to get you to see here is that that quantity squared, it sure looks like it's that exponent rule, but it's not because of the minus sign or a plus sign on a different problem. So the only way to do this safely is to write it out twice, because that's what exponents mean. Okay, and then fill out your matrix. If you do this, I'm just going to jump to the answer. It's 4x squared minus 28x plus 49. Trust me, I've never made a mistake yet. Okay, so be careful. I know you guys are going to come back on Tuesday with lots of questions related to this, but I'm warning you now, okay, about quantity squared. You need to be careful about how you attack it. All right, as far as I know, let me double check. I think Mom is open. Has anybody gone to Mom and ignored me and tried it?
It is. It's open.
It's open and going? Okay. I will stay online for until about 9 o'clock in case you have questions. You have until midnight tonight to finish it off. And don't forget the chapter 4 homework, and I'll see you next week. Bye.
Thank you.
Mhm.
Bye, Professor.
Thank you.